Welcome back, everybody. Very special day today. We probably have the top mind in terms of respect and funding from the government and everything else. We have the leader of the Galileo Project. We have a Harvard University professor. The man who brought us Oumuamua. We're talking about Avi Loeb, and he's on the show today.
Professor's in the house, right?
Yeah, absolutely. Yeah. UAP Studies professor is in the house.
Yeah.
And we got some viewer questions that we're going to go over as well. We're going to ask Avi. He's told us we can ask him anything, and we're going to ask him anything. And we're going to see what he has to say. I know he's very well spoken. He's going to try to shed some light on, are we going the right direction? Is he finding anything cool? What's the right way in his mind to get more actual evidence? Because there's a lot of talk, not a whole lot of evidence, and he's about finding it. So I'm super pumped to chat with this man. Jay, are you ready?
Oh, I'm ready to do this.
Let's do this. We'll be right back with Mr. Avi Loeb on UAP Studies Podcast. Welcome back to a very special episode of UAP Studies Podcast. My name is Louis Borges. Joining me as always, my good friend and illustrious co-host, Jason Gilmet.
Oh, thank you. You are so kind. Illustrious co-host. I love it. How are you, Louis?
Yeah, and it's a good day today. We're chatting with one of the brightest minds on the topic, somebody very current and somebody in a very interesting role. And I mean, everybody's heard of Avi Loeb. I have just some of his credentials here. I mean, the list could go on forever, but essentially we are chatting today with a professor of science at Harvard University. He has a PhD in theoretical physics. He's a best-selling author, director of the Institute for Theory and Computation, and he is the head of the Galileo Project. And that in itself is a lot. So we can only pick his brain so much in the hour that we have here, but we're also going to ask some viewer questions and get to know him and get to know what we can expect coming in the future. So a very warm welcome to our good friend, Mr. Avi Loeb.
Thanks for hosting me. And you could have saved some time if you just defined me as a farm boy. I was born on a farm, and that pretty much shaped my scientific career.
At least your hard work ethic, for sure.
Oh, yeah.
Well, that's one thing. And the second is I became connected to nature much more so than to people. So I don't have any footprint on social media, and I want to learn from nature without any prejudice, with humility, basically, because very often nature gives us a message that we haven't expected. Just a century ago, as an example, we discovered quantum mechanics, and that was completely counterintuitive to many people, including Albert Einstein, who fought for many years on the wrong ideas of how to interpret quantum mechanics. But we found it experimentally, and obviously nobody would have expected it to start with. And now, a century later, we use it to construct all of our technological gadgets like cell phones, computers. We are communicating thanks to the understanding of quantum mechanics. So my point is, nobody would have expected quantum mechanics to be the way it is, and we still don't fully understand it. And therefore, we should be, humble and try to learn from nature. And it's a dialogue with nature. It's not a monologue. Many of my colleagues feel that they are smart enough to have a monologue, to say to nature what it's supposed to be, like there should be extra dimensions, there should be supersymmetry, all kinds of statements, and then they do mathematical gymnastics and demonstrate that they are smart. My point is that science, is just as when I was a kid, it's a sort of a learning experience. You learn about the world, and you have to be humble because very often nature surprises you. And if you pay too much attention to people, you can go in dark alleys that lead nowhere. You can spend tens of billions of dollars in searching for things that do not exist. And an example for that is the Large Hadron Collider, searching for supersymmetry in the natural parameter space that a lot of scientists were arguing must be there, and even the dark matter was supposed to be found. We didn't find those things. And my point is that should teach us modesty. And of course, that's on the negative side of expecting things and not finding them. But there is the other side, which is not expecting things and then finding them to our surprise. And, we will talk about it. But in my mind, the interstellar objects are exactly that.
So what is a brilliant science mind like yourself doing, getting into UFO and UAP weirdness and opening themselves up to this barrage of rocks and people throwing stones? What made you want to get into this particular, and thank God you have, we really appreciate your contribution. Absolutely. I just want to say that. But what made you want to go down this rabbit hole, and put your license and your career and everything else on the line?
Well, it's paying attention to intriguing evidence, that's all, and not paying attention to people. It's really strange on this subject. The community of people talking about it is polarized as much as politics. In politics, you find people on the two extremes making statements that make no sense. And they fuel each other because one extreme says nonsense and the other extreme says, look at this nonsense, and therefore they go the opposite direction. So the same happens in this case. There are people who are believers. They had some experience at age 7 in their bedroom. They saw some lights. To me, as a scientist, that makes little sense. Science is not about belief. And a 7-year-old kid is not a scientist. And the fact that the kid saw some lights, that could have been coming from, the window somewhere. I mean, that is not evidence. And therefore, the belief of that person is nothing, is no evidence for anything, okay? And then on the other side, you have scientists who ridicule the study of unidentified objects, of interstellar objects that are nothing familiar, and we can talk about it more. Only over the past decade, astronomers discovered the first interstellar objects that came from outside the solar system through telescopes. And 2 of them were discovered by my student and me. They were the first 2 meteors, one from 2014, another one from March 2017. The third one was discovered by a telescope in Hawaii in October 2017, and it looked very weird, and we can talk more about it.
That's Oumuamua, right?
And then, that was Oumuamua, on which the book that I wrote, Extraterrestrials, is based. And I would much rather show a photo album if I had access to close-up photographs of this object. They say a picture is worth 1,000 words. In my case, it's worth 66,000 words. I would never write a book if I had a photograph. So to me, it's all about evidence. And if the evidence looks intriguing, like all 3 objects appear to be unusual. The first 2 meteors were tougher than iron, and they were outliers relative to the space rocks we had seen before. And Oumuamua was really weird because it had an extreme shape, most likely flat. It was pushed away from the sun by some mysterious force without showing cometary tail. It was definitely not a comet. And the question is whether any of them was a spacecraft or some artificial object. And to me, that's what brought me into the subject. The fact that these objects, the first ones discovered, the first 3, looked peculiar. They didn't look like something familiar. And then, of course, the US government started talking more seriously about unidentified aerial phenomena. So that was added to the basket of things that I really care about. The evidence is not conclusive on any of them, but it's sufficiently intriguing for me as a scientist to go out and search for more evidence. However, many of my colleagues prefer to brush it under the rug and just ignore it and say business as usual. And it gets to an extreme situation. I can give an example where a colleague of mine wrote a couple of months ago, wrote a review paper in a very distinguished journal called Annual Review of Astronomy and Astrophysics. That's the place where you put the most prestigious review papers on subject in astrophysics. And he wrote a review about Oumuamua. So that was supposed to be the authoritative summary of what we know about it. And he wrote an email to me saying, I'm just finishing the review paper about the comet Oumuamua. So I asked him, how can you call it a comet? There was clearly not a cometary tail, no evidence for any carbon-based molecules around it because the Spitzer Space Telescope looked very deeply, couldn't see. It was definitely not a comet of the type that we are familiar with. So he replies, well, I have a theory that in fact it was, and it didn't show a cometary tail when we looked at it, but when we didn't look at it, when we looked away, it had a cometary tail. And I told him, to me, it sounds like going to the zoo and looking at an elephant and then saying this is a zebra and it shows its stripes when we look away from the elephant. And that makes little sense. Now, the fact that a person from the mainstream who writes a review about the object, which is supposed to summarize everything we know, goes in that direction, tells you a lot, because it says, you know, that person and the community that justifies it would much rather speak about the object in familiar terms, call it a comet, even though it's not a comet, so that they would feel comfortable and move on and ignore it. And that, again, is completely unreasonable, okay? So I'm trying to follow common sense. I'm trying to go in the middle and just collect more evidence, because I say here is something unusual, you know, and it's quite possible that it's a probe from another civilization. Why not allow for that? We sent out 5 interstellar probes, you know, ourselves in 50 years, okay? And so other stars formed 5 billion years before the sun, and if there was a civilization like ours, it could have sent such, you know, chemical rockets billions of years ago, and it takes only 500 million years for a chemical rocket to traverse the entire Milky Way galaxy, so they could have arrived here. So what is wrong with considering something that we ourselves are doing and then just, you know, checking it out, collecting more evidence? And you know, there are many reasons why this is not popular in the scientific community. One of them is, of course, the other extreme of people claiming everything is extraterrestrial, but without any proof. But also, you know, experts prefer to explain everything they see based on their past knowledge, because that's where their reputation hangs, and their person, you know, their stature, and so they would much rather not go into new territories, and they would claim that everything in the sky is rocks, even if it's a rock of a type that we've never seen before. Just like a cave dweller, when finding a cell phone, would argue it's a rock of a type that I've never seen before.
Oh, actually, good point. Yeah, so when you were talking about how nature, like you observe nature, you're a big fan of nature, and one thing that I appreciate is that you understand that if there's such things as extraterrestrial visitations or other beings out there, it's part of nature. It's part of the galactic nature. It's not just, you know, us here thinking that we're by ourselves, when there might be teeming of life out there in the universe.
Yeah.
So it's great to have that and to hear that. And there's a lot of you know, people saying reminiscence or of, you know, John Mack. When John Mack was at Harvard, he had a hard time for a while. Like some people sort of giving him a rough time for his ideas and conceptions.
Well, that's quite different, because he was interested in the psychology of people who claimed to be abducted. I don't consider humans as scientific detectors, because humans are often, you know, hallucinating, have wishful thinking. You know, you cannot, in science, when you do physics, you cannot use eyewitness testimonies to substantiate any claim, scientific claim. He was just focusing on humans, so that's a very big difference. And you know, humans. Maybe, you know, those people who claim they were abducted, who claim they've had experiences, they have something in common. So the best you can hope by examining them is to study what do they have in common. They could all be illusioned by the same mechanism. I don't care about it. I want to find what is out there in the reality that we all share. Just like, you know, the question of whether the Earth moves around the sun or the Earth is at the center of the universe. That's not a question that you can resolve based on what people tell you, because, you know, for 1,000 years, people believe that we are in the center of the world. And you know, that was true also just 2 decades ago in my home, when my daughters, you know, when they were infants, they thought that they're at the center of the universe, because the universe for them was our home. They realized that we all run around them. And of course, they had a psychological shock on the first day in the kindergarten, because they found a smarter kid on their block. And that was really traumatic as far as they were concerned. So my point is, our civilization will mature when we meet others. And until then, people tend to be quite arrogant because that gives us a good feeling, to think that we are the center of the world, but then we realize, oh, okay, the earth moves around the sun. We cannot really ignore that. We cannot ignore the facts after we have enough data. Initially, Galileo was put in house arrest. Today, he would have been canceled on social media. But eventually, those philosophers who didn't want his voice to be heard, they would never be able to reach Mars with a spacecraft because they thought that Mars moves around the Earth. And that's the wrong idea. Reality is whatever it is. That's my point, that people can say whatever they want just to beautify reality. Just like people put makeup so that they look better, people to take recreational drugs so that reality will appear much more appealing to them. People put goggles that bring them to the metaverse, where they always look like Brad Pitt and they live among celebrities. The question is, okay, they feel better this way, but it's not the reality that we all share. And the reason I really focus on the reality that we share, I would like to see the pimples on the face of reality. I don't want any makeup. The reason that I want to do that as a scientist is because only when you understand the actual reality that we all share without any illusions, you can adapt to it. So if you realize that the pandemic is caused by a virus, you can try and develop mRNA vaccines, okay? If you realize, that gravity is a curvature of space and time, you can design GPS systems that allow you to navigate. If you understand quantum mechanics, you can develop cell phones and computers that we all use. You can develop the internet. So the point is, you can shape reality only if you understand it. If you have the wrong ideas about reality, you will just go in dark alleys that lead nowhere. Just like those philosophers during the days of Galileo, they would never reach Mars. They would send rockets all over the place, and these rockets will go in directions that will never get to the destination. They would waste a lot of money just because they had the wrong idea about reality. So I think it's our duty to try and understand reality so we can adapt to it. And that includes not just what happens on Earth, it includes what happens in space. So the Earth moves around the sun, that's, of course, old news. But then the question is, are we really the only kid in our cosmic neighborhood? And my guess, probably not. I don't think we're special. I think it's arrogant to think that we are special and unique. And in fact, we now know that, about a few percent to 100% of all the stars, like the sun, have a planet the size of the Earth, roughly at the same separation. So, it's clear that what we find in our backyard is not unique, and the dice of intelligent civilizations was rolled billions of times within the Milky Way galaxy alone, okay? And so we're probably in the middle of our class of civilizations, and we just started our science and technology a century ago. So, that it's very unlikely that you would find someone exactly at your level. Most likely, other civilizations are either much more primitive than we are, the way we were, let's say, 1 million years ago, or much more advanced than we are. Just because a century of science and technology is just one part in 100 million of the age of the sun, so it's a very short window. So it's unlikely to find them exactly in that century. So if they are much more primitive, we will need to board the ship, land on their planet, and start searching through the trees to find them the way we were, let's say, 1 million years ago. That's a lot of work. I don't think we will ever do that. And the other way, if they are much more advanced than we are, we don't need to do much. We just need to look up and check intriguing objects because they reached us, and we can learn from them. So that's really the opportunity. We can learn from them. We can become smarter. We can get a glimpse at our future. There are lots of benefits to being open-minded.
So tell us a little bit about the Galileo Project. A lot of people have heard of it. They know a little bit about it. So from the source itself, what is the Galileo Project and why is it important?
Right. So in June 2021, there was a report delivered to the US Congress about unidentified aerial phenomena. And a few weeks before the report became public, Bill Nelson, the head of NASA, said that scientists should get engaged in studying UAP and understanding their nature. the government is not a scientific organization, and if a government official says that, he used to be a senator, he saw also classified data on UAP, so I took his words seriously, and I approached NASA and basically said that I would be glad to make their boss happy. And I was asked to submit a white paper about it, and I heard nothing in return. So around the same time, a few multi-billionaires decided to contribute to my research account at Harvard. Without me doing any fundraising. They were inspired by my book, Extraterrestrial, and I decided to establish the Galileo Project, simply to do what I was trying to get NASA to do itself. And it's, first of all, build a suite of instruments that will monitor the sky. The sky is not classified. The reason that the most juicy data within government is classified is because it was taken by classified sensors, and the government doesn't want adversaries to be aware of the quality of the sensors being used, and that's why the data is not released. But if you collect the same quality data or even better data with state-of-the-art instruments that you buy off the shelf, just looking at the sky, and by the way, astronomers, even though they look at the sky, they look at a small portion of the sky, or they look at very distant sources. They never try, if there is an object moving across the sky, they ignore it. And so we had to design a new suite of instruments that are not currently available in astronomical observatories. So that's the first goal. The first goal is to identify the unidentified. The second, and to help the government figuring out what it is. And, it's probably a mixed bag where, most of the objects are either human-made, they could be used for espionage by other countries, or they could be drones, airplanes, weather balloons, satellites, and so forth. And then another part is just natural on Earth, like birds, insects, and so forth. And the question is whether there is anything else. And I wouldn't be surprised if most of the objects have mundane explanations, but it's sufficient to have just one object that is beyond any reasonable doubt of extraterrestrial technological origin. In other words, you see bolts and screws on it, maybe even the label saying made on exoplanet Y, and you see it behaving in ways that our technologies cannot reproduce. And I should emphasize, we do not imagine new physics here. New physics is a very high bar, that physicists are trying to find new physics in all kinds of laboratory experiments. And it takes decades and a lot of effort to find any minute deviation from the known physics. Just to give you an example, a decade ago, there was an experiment called Opera that reported neutrinos, that these are particles that are quite elusive, but the claim was that they move faster than light based on what this experiment detected. And then there were, tens of papers written about what that may mean if neutrinos move faster than light. And that could have important implications, because you can transmit information faster than light. You can basically beat the stock market, because all communications relating to the stock market move at the speed of light. And if you can relay information faster than light, then you can make your transactions before anyone else. So that, it has huge implications if something moves faster than light. So anyway, then because of all the attention, they checked the experimental setup, and that would have been, of course, new physics. And then they realized that one of the cables was loose in the experiment. So it was clearly a problem of a loose cable. And that's why they got to the wrong conclusion. And, this experiment was very carefully designed and monitored, and yet they had some error in the way that they connected the cable. So what I'm saying is it's very difficult to find new physics. For decades, we did not find new physics. It's all about what was known since the 60s, the standard model of particle physics. And the Higgs boson, was discovered, but it's old news. It was expected from the 60s. So my point is, new physics is a bar that one should only exceed if the data is extremely good very high quality, so that there is no doubt, there is no mistake in the way the data was collected. And one has to be very careful before claiming new physics. And, on that front, I'll give you an example. Just a few months ago, there was a report from Ukraine by some astronomers claiming that they see dark objects at a distance of 10 kilometers that move at 15 kilometers per second, above the escape speed from the Earth. And they said these are unidentified aerial phenomena, and they are potentially of extraterrestrial origin. These are dark objects. And I looked at their paper and immediately realized that if indeed you had an object, they claimed it's 10 meters in size, moving at these speeds, that would have created a huge fireball in the atmosphere of the Earth. And you cannot avoid the friction with the electrons and atoms and molecules in the air, because they claim that the objects are dark. That means that they block light, they block electromagnetic radiation, so they interact electromagnetically, and that means that it's inevitable that they would interact electromagnetically with electrons in the atmosphere. Just, they cannot distinguish the electric field of electrons in the atmosphere from the electric field of radiation. So the point is, the laws of physics require that there would be a huge fireball around them at these speeds, and then they would not be dark. And then I said, okay, well, if they got the distance wrong by a factor of 10, if these objects were closer to us, then they would be a meter in size, they would move 1.5 kilometers per second. That's exactly the properties of artillery shells. And you would expect a lot of things moving at this speed, of this size, over the sky of Ukraine during a wartime, okay? And so I suggested that they got the distance wrong because they measured it from one site. Usually to get the distance right, you need multiple sites. And then I was attacked by people who are advocates of UAP, and because they made analogies with past reports from 20 years ago, like, for example, the Nimitz. That has nothing to do with what the astronomers in Ukraine were reporting about. The only way to respond to my criticism would be to say the distance estimates are accurate, actually, because of this and that. But nobody replied this way. And also the National Academy of Science in Ukraine basically said the same thing as I said. They said that the distance estimates are not accurate. They also had bright objects, one of which they measured the distance to from two sites, so that you can rely on, and they found an elevation of 1,000 kilometers. I just put in Google spy satellites, and I saw that the elevation of 1,000 kilometers is typical for a spy satellite. So obviously that could be a spy satellite. You can't write a paper saying these are unidentified objects that are potentially extraterrestrial if you didn't rule out the possibility of a spy satellite in the case of the bright object, or artillery shells or bullets in the case of the dark objects. And these people were claiming that. And then the UAP advocates were saying, well, it's new physics. And I say, that's completely unacceptable. You cannot argue in favor of new physics if the evidence is sloppy, if the evidence is not robust, if you don't have triangulation. Okay, so on the one hand, I get rocks from the side of the believers. On the other hand, I get rocks on the side of the skeptics because they don't want even to discuss this subject. But I don't care, because I just follow the evidence. If the evidence is not conclusive, if it's doubtful, we should seek better evidence. So that's the Galileo Project in terms of UAP, collecting high quality evidence so that it will be clear what the objects are, and we are calibrating our instruments. By the way, this week is very important because it's the first time we're starting to collect data, and we will analyze it with artificial intelligence algorithms. So that's one branch of the Galileo Project. Another one is to design a space mission that will rendezvous with the next Oumuamua. There is a dating app, the Vera Rubin Observatory in Chile, that would alert us within a year to objects like Oumuamua, and then we could, in principle, send a camera that will come close to the next Oumuamua and take a close-up photograph. So we got about $250,000 for the design of such a mission. So we are working on that. And the third branch is to scoop the ocean floor for the fragments from the first interstellar meteor meteor that landed in 2014 near Papua New Guinea, about 100 miles off the coast. And for that, I received $1.5 million in a donation that funds it entirely. And we have an excellent team that has some of the best experts in the world in ocean expeditions. And we plan to go next spring and basically scoop the ocean floor, find those fragments, because we know that this meteor was tougher than iron. It was tougher than all 272 other space rocks in the catalog of meteors that the government compiled. So it's clearly an outlier. It's the first interstellar object ever discovered, roughly 0.5 meter in size, and it exploded above the ocean surface at an elevation of about 19 kilometers. And then the fragments from it should be on the ocean floor. And, it released a few percent of the energy of the Hiroshima atomic bomb. So that was quite a powerful explosion at 4 a.m. near Papua New Guinea in 2014. I'm sure it woke up some of the residents there. And we are planning to figure out what the object was made of. Was it rock, an unusual rock, perhaps an iron meteorite, or was it artificial in origin, if, for example, made of stainless steel? And I already promised the curator of the Museum of Modern Art in New York City that if we find any gadget on the ocean floor, I will put it on display in New York City, because it would represent modernity for us, even though it may represent ancient history for the senders.
Oh, wow.
You actually answered one of our viewer questions just in regards to the whole Ukrainian UAP report. And the question was from a gentleman named Dennis, I think it's Dennis Stefan or Dennis Stefan, but he wanted to know that if something moving at that velocity would create a fireball, how does that leave room for the Nimitz? And you mentioned you get rocks from both sides, right? The UFO community and the skeptics and the scientists. So he basically wants to know, if that thing was moving so fast it should have had a fireball, why didn't it tic-tac? So what are your thoughts on that?
So my thoughts are, we don't have the data. We just have eyewitness testimonies about what happened near the Nimitz. And there were reports that the objects were moving extremely fast. But just imagine a population of multiple objects, okay? And some of them come in and out of view, let's say of a radar system or an infrared sensor. So you see an object at one location, and then it goes out of view, and then another object, completely independent of the first object you looked at, shows up behind you, okay? Now, you might argue, oh, it's the same object, it was moving extremely fast, but it's actually two different objects. And the only way for us to tell is if you find some marker, some flag on the object that tells you that it's the same. But without that knowledge, it could be a population of objects and you would just see them coming in and out of view. Another possibility that one should keep in mind is that it's not a real object. You are familiar with this game that one plays with a laser beam, tricking a cat as if it's a real thing, so you just move it on the floor, the spot of the laser, and the cat ran after it, right? So the cat thinks it's a real object, but in fact, it's just the spot of the laser beam moving around, and it can move really fast without doing anything, to the air without doing. So the point is, we don't know why the government kept the data from that incident secret. It's possible in my mind that it was one branch of government that was developing some kind of new technologies, let's say an unusual set of drones back in 2020, back in around 2000, so 20 years ago, that back then, people in the military were not even imagining, okay? And then if you had a population of those, you could have one being mistaken for another as if it's moving really fast. Or it could be lasers that were used at the time. Now we know that lasers are used also as weapons in the Navy. So it could be any new technology that was tested. And then, of course, they didn't want the data to be available because it was all secretive at the time. So that is a possibility. And by the way, I don't really want to touch any classified data or information that belongs to the government because it's a matter of national security. What I want to do is collect new data because the sky is not classified, and collect it with instruments that I fully understand without relying on eyewitness testimonies. These instruments will record something in multiple wavelengths. So the Galileo Project has infrared, radio, and optical sensors that cover the entire sky at all times. There is an audio sensor, magnetic field sensor. So basically, we'll have a full video of the sky with audio at all time, like a movie, and then we will analyze it. And obviously, we are calibrating our instruments. We understand fully how they operate. And let's see if we find anything unusual. So rather than, imagine what the military personnel were seeing back then, 20 years ago, now we have much better instrumentation. If there is a phenomena out there that evaded explanation and is of extraterrestrial origin, we should be able to see it. And, that's the more healthy approach to take, because otherwise you can speculate forever, and that would not convince the mainstream of the scientific community so that we can move forward. Now, of course, the government may have some data that we don't have access to, but I find it hard to believe that they would declassify. I don't want to ask them to declassify it because it will take forever. And I would rather collect data about the sky myself. And that's what we are doing with the Galileo Project. And so just stay tuned, or hopefully within a year or two, we'll have something interesting to say.
And as far as doing the expedition that you guys are heading forward, you said in the spring of next year?
Yes.
Yes. So how difficult is it going to be to find those fragments? Do you think they're going to be quite easy to find, or is it going to be like a needle in a haystack type situation?
Well, we need to visit the location of where the fragments are expected to be. And for that, we are trying to get the location precise as possible by using government data. So we are trying to get the cooperation of the US government to know precisely where this fireball was observed, so that we minimize the area that we search over. But you have to understand that once the object exploded, in fact, we have a new scientific paper about it, it produced fragments of different sizes. Most of them are around a millimeter, the head of a pin, roughly the size of the head of a pin. And for small fragments, the friction with the air would bring them down, just like droplets of rain. They would be stopped by the air and just fall down. And they were very hot, of course. They were melted material. And then the bigger fragments could continue along the path of the original meteor. And so you end up distributing the fragments along a strip, with the lightest ones just below the explosion site, and the heaviest fragments aiming in the same direction as the meteor was aiming. So we want to find this strip, and the ocean is fairly deep out there. It's about a mile deep. So we are designing special machinery that will include a sled with a magnet and also a net behind it that will collect the fragments. And, it's possible that we will not find anything because, in principle, everything could have been vaporized, for example, or that we visit the wrong place. But we very much hope that we will find something, and we don't need more than a few grams of material in order to figure out the composition. So we will do our best, and I'm willing to sleep on the deck, under conditions that I haven't experienced since I was a paratrooper in the Israeli military back in my 20s, some 40 years ago. We should see what we find. It's really exciting, and because we are doing science, we are not, this is the first object from interstellar space ever spotted, and we have a chance of putting our hands on the material. And if you wanted to do it in space, it would be a mission that costs more than $1 billion. So it's about 1,000 times cheaper to do it here on Earth, and that's what we are doing.
So the
Nice.
significance of this is that it's a rock that originated outside of our galaxy. Is that why it's so significant?
Outside of the solar system. So the Milky Way galaxy is a collection of tens of billions of stars, many of which are just like the sun. So that's a galaxy. A galaxy is a collection of stars, and then beyond the Milky Way galaxy, there is the entire universe that is made of about 1 trillion galaxies. Okay, so altogether, the number of stars and the number of Earth-like planets in the observable volume of the universe is more than the number of grains of sand on all beaches on Earth. It's 10 to the power 21. So the huge number. And that's why we should be modest and not assume that we are that Albert Einstein was the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. There must have been scientists on other planets billions of years ago that were smarter than Einstein. And the civilization that benefited from their wisdom could have sent probes into interstellar space that would have reached us by now. And we just need to search for that. And we can learn from them. Why not look over the shoulders of a smarter kid, in our class and learn from the answers that they gave, simply because they had more time, and what I keep saying is, we tend to think that we are at the center of the stage of a cosmic play. But guess what? We are not at the center of the stage. We know that the Earth moves around the sun moves around the center of the Milky Way galaxy. It's one out of tens of billions of stars like it, and then the Milky Way moves in some random direction relative to other galaxies. So we are not at the center of the stage, that's for sure. But moreover, we just arrived, the human species was just formed a few million years ago, and that's a tiny fraction of the age of the universe, 13.8 billion years. So, if you are not at the center of stage and you just arrive at the end of the play, there is a very simple conclusion. The play is not about you.
Yeah.
Okay. We refuse to accept that, but it's obvious. Any kid would tell you that if you're not at the center of the stage and you arrive just in the last moments of the play, it's not about you. Now, if you want to find more about the play, you better find other actors who have been around for longer, and they might tell you what it's about. And that is the correct approach.
So this is just, again, the theorizing here, but do you think it's sort of a cosmic thing that evolution, for the species that have evolved faster, more than us, or is just scientifically more inclined than we are? Is it sort of not their responsibility, but they sort of help other species? You know what I mean? Like, is it a thing that might be universal, that to help each other out? One theme that we run across a lot in this podcast is the theme of consciousness. Now, we do look at different aspects than you, because you got your your specializations that you focus on. We look at different things, and we keep hearing about consciousness. It seems to be something that we keep hearing, and that these crafts operate on consciousness, the ones that are anyways reported in our skies, not the ones that are out there, the ones that you're searching for. But I keep thinking, is that like a cosmic thing that, visitation is a normal thing? Like, once we humans have evolved to a point that we're able to explore other civilizations, would it be our duty at that point to sort of help them along the way, or at least give them little nuggets of information?
No, I don't think that's the motivation, and it will take us a while to figure out, what their purpose is, because the way I imagine it is that there would be far more. I mean, whatever we find, these objects, which will not carry biological creatures, because humans, for example, were never designed to survive in interstellar space. The trip with chemical rockets takes 50,000 years to reach the nearest star, and hundreds of millions of years to cross the Milky Way galaxy. So, that's not a short time, and you can't enjoy the trip. And also, you would not survive the bombardment by energetic particles, the vacuum out there, and so forth. It makes much more sense to send electronic systems that have artificial intelligence. I call them AI astronauts. And that's most likely what we will find. We will find the technological gadgets with technologies that are far more advanced than we possess. But that's not because the other civilization evolved faster than we did. It's because they started earlier. I just mentioned most of the stars, were formed 5 billion years before the sun. We know that because we observe the star formation history of the universe. So the sun is a late bloomer. So, in fact, within 1 billion years, the sun will boil off all the oceans on Earth, and humanity will not survive beyond that time for sure, irrespective of what we do. And other suns have reached that milestone. Basically, the host star, destroyed, sterilized habitable planets around them. Okay, and so whatever civilization may have existed is, dead by now, and it's possible that they had cried for help at the last moment when the star basically burned up the surface of the planet. So there were cries for help, but it fell on deaf ears here on Earth because there were only microbes on Earth at the time. We just started our life here on Earth, and there was no intelligent species here on Earth at the time. So there could have been a lot of civilizations before us that are dead by now, but they could have sent equipment to space, and we can find it. And it's just, every morning I jog at 5 a.m. at sunrise, and I jog through the local woods, and there is this philosophical question: if a tree falls in the forest and there is no one to hear the sound, does it actually make a sound? My point is, I do see those logs of trees that fell without anyone hearing their sound. Okay, so I can tell that there was a tree because I see the trunk and I see the log, and it tells me that there was a living tree before the log fell to the ground. And in the same way, we can find, those AI astronauts, technological equipment that was sent to space from civilizations that are dead by now. Okay, that's like archaeology. You find relics. And I think that is the correct thing to do, rather than wait for a phone call from those civilizations, which is pretty much what we've been doing for 70 years in the context of SETI, the Search for Extraterrestrial Intelligence. We were waiting for a phone call. We were looking for radio signals. The correct approach is to check your mailbox. Maybe you have packages in the mailbox that accumulated over time. It's a very different approach, and that's what I'm trying to promote. It was not practiced in the past. And the strange thing is the SETI community has a problem with that. They ridicule the discussion of objects as potential, signatures of extraterrestrial intelligence. And you ask yourself, why would the SETI community not include that as part of? In fact, they banned discussions on UAP in any conference of SETI.
Really?
That was banned a year ago. Yeah. Nobody is allowed to discuss it.
Oh, wow.
So you ask yourself, why is that? And the only way I can understand it is if the SETI community is trying to signal, it's sort of like virtue signaling, trying to signal to the mainstream, look, this subject, there is a subject that is even more speculative than what we are doing. And we don't want to consider it. We are sort of middle way, and are trying to appease those skeptics and basically say, give us a little money so we can do our work. And my point is, one should not be apologetic about it because there are all these unusual objects. Let's figure them out. And if the US, under these circumstances, it's obvious why the US government would be the first to discuss unidentified objects because it's their day job to monitor the sky. They don't have the luxury of ignoring the sky. Okay, so they monitor the sky and they see things they don't understand. So if there is anything out there, the US government will be first to notice it. And that's the reality that we face. And so I think it's our civil duty as scientists to help the government figure it out. Now, if we don't find anything outside of this earth, so be it. That's the way science is done. But we definitely have to examine what the government is reporting to figure out if it's really outside of this earth. And that's also exciting. I don't see any problem with that. It's actually just like a kid wondering what the world is about, and we should do it with modesty. We should do it while being agnostic, without prejudice, and just get better data.
I love the way that you think. I love your approach to this. I love hearing somebody of science like yourself and quite high up in science, all the way to Harvard, for crying out loud, saying, that we should look at this, that this is something to really, take a serious look at it and not dismiss it anymore, the way that people have in the past. So that's amazing. Louis, do you have any final questions for our guest today?
No, I just want to give a very warm thanks to Mr. Avi Loeb. Again, you're ballsy. And I know that's blunt, but it's true. I mean, you could easily be studying different things or doing this quietly, but you're not scared to go against some of those opponents and say, well, why not talk about this? Like there's no proof one way or the other. Let's find some proof instead of conjecture and just having your idea, my idea. It's all theology, and let's get something that's actual nuts and bolts, right? We hear that term a lot.
Yeah.
We want the nuts and bolts, and now we got a guy trying to find it, and he's getting stoned. So it's important to have people like yourself. And again, if you were doing something that was crazy or against the government, you probably wouldn't be doing it. Somebody would have silenced you or said, hey, this is something you don't go near.
So I just try to follow common sense. And the two things I wanted to mention. One, we live for a short time. Okay, so instead of spending our time on social media and seeking as many likes as we can, we better, learn from nature, figure out what is out there. And that implies collecting evidence. And I see the back and forth conversation as waste of time, and eventually when the evidence will be beyond any reasonable doubt, whoever doesn't believe it would look like a nut, okay? Because we would have the evidence. And of course it's a circle. If you don't seek evidence, you will never find it. So I'm trying to break that mold, okay? And the second thing is science should be fun. It's not supposed to be boring. It's not supposed to be about the egos of experts claiming they know everything, that everything in the sky must be rocks. Yeah. It's not about that. It's about, okay, here is something intriguing. It's exciting. Why don't we figure it out? Just like kids. And, the personal attacks that I get sometimes, I think the biggest impact is that they deter young people from taking the path not taken, and that suppresses innovation in science. That's very bad for science, for academia in general, and so that makes me even stronger. I told my publicist that by now my skin turned into titanium. I don't really care what other people say. And the other thing, in June 2023, I will have a new book coming out. It's called Interstellar, and that will speak about the implications to humanity of whatever we find.
Nice.
Amazing. Well, thank you so much, sir. We can't thank you enough. We'd love to have you back on again. Maybe next year you're doing some ocean scrubs. You find something cool. Come on back on and share it with our audience and our viewers.
I'll be delighted. Thank you.
Thank you so much, Avi.